Hi guys, so what we've got in front of me is the new worksheet of the week. I'm going to work through a few problems so that you can do the rest by yourself. So let's look at the first four problems. It says solving each equation by elimination. Number one, I see right off the bat that this negative 5x and positive 5x are able to cancel each other out very easily. So hopefully we should be able to do that all by ourselves without manipulating anything. I want to try and walk through something a little more difficult, something like number 4. So here my variables, my numbers aren't really lined up. They don't look exactly the same. So I'm going to start by rearranging my equations just so that all of my variables, all of my numbers line up right under each other. So I'm going to make it 8x plus 9y minus 27 equals 0. Okay, all I did was move that negative 27 to the end of the equation and left that 0 on the right side. For the second equation, I want to make my 0 on the right side just like how my first equation looks. And I'm going to have this negative 10x minus 4y plus 12 equals 0. Okay, so now we're a little bit more lined up. And here my 8x and negative 10x and 9y and negative 4y, none of these match up the way I'd like it to. Now we can either multiply one or both of the equations or divide one or both of the equations. Either way will work. In this case, I see my 8x and my 10x. I know that both of those can be divided so that they become 2. So I'm going to divide both equations so that I can end up with 2x. So I'd have to divide the first equation by 4 and the second equation by 5. Okay. And this is going to give me some decimals, some fractions on my other numbers, and that's okay. But this method, if you're not comfortable with decimals or fractions, might not be the best for you. You might want to just go and multiply so that you get the same numbers, okay? But I want to show you this division way. So my first equation, I'm going to end up getting 2x plus 9 over 4y minus 27 over 4 equals 0 because 0 divided by anything is still 0. And this one is going to end up being negative 2x minus 4 fifths y plus 12 fifths equals 0. Okay, so now I've easily made it so that my 2x over here and 2x here will cancel each other out. Now what I have to do is combine my fractions, 9/4 and subtract 4/5. So remember when you're adding, subtracting fractions, 9 over 4 plus 4 over 5, I need some common denominators. So I need to multiply this fraction by 5 and this fraction by 4. And that's going to give me 45 over 20. And I mistakenly said add. We want to subtract because that's a negative 4/5 minus 16 over 20. And then when you subtract or add fractions, you keep the denominators the same and just add across the top, or add or subtract across the tops. So I'm going to end up with a positive 19, 29. 45 minus 16 is 29. So a positive 29 over 20y. And then I have negative 27 over 4 plus 12 over 5. I need common denominators again. So 5 and 4. And that's going to equal to 135 over 20 negative plus 48 over 20. And that's going to give me a negative 87 over 20 equals 0. Okay. Same thing as if I had whole numbers. I'm going to add my 87 over 20, bring it over to the other side. And I'm left with 29 over 20, y equals 87 over 20. Now both of these fractions are being divided by 20. So I could multiply the entire equation by 20 and get rid of them. So it's 29y equals 87, and then divide by 29. And finally, I ended up with y equals just 3. Okay. I know that was a long process because I did it in that fraction way that made me have to do these common denominators, but it works out, okay? So remember, you have options. It doesn't always have to be one single way. But now I need to solve for x. So I know y is equal to 3, and I'm going to grab this second equation down here. Okay. My 0 equals negative 10x plus 12 minus 4y, and plug it into there. 0 equals negative 10x plus 12 minus 4 times 3, because that was y. So 0 is equal to negative 10x, 12 minus 12, oh, plus. So these cancel, and I've got negative 10x equals 0, so x must equal 0. All right. Let's look at some graphing here. So number 7, notice how these are in standard form. Standard being that ax plus by equals c. And I'm going to show you how to graph like that one more time. So when I'm looking, let's start with my first equation in green. Okay. So 5x minus 7y is greater than 49. What I know is that if I wanted to solve for my x-intercept, that means y has to equal 0. So then I change my equation to look like 5x minus 7 times 0 is greater than 49. Then I know 5x is greater than 49. Divide by my 5. X is greater than 49 over 5, or 9.8. So that means one of my points has to be 9.8 on my x-axis, so right around there. Okay. Vice versa, if I wanted my y-intercept, that means x is 0. So we do the opposite. 5, 0 minus 7y is greater than 49. We've got negative 7y is greater than 49. Divide by negative 7. Remember that when we multiply or divide by any negatives, your sign flips. So y is now less than 7. -7. Okay. So y, on my y-axis, I need to have a point at -7. And remember that when we have symbols, your less than, greater than signs, and there's no equal to sign underneath, it is a dashed line. Okay. So that's my green line. And we'll talk about shading in a second. Let's focus on my second line. I've got 4x plus 7y is less than or equal to 14. So same steps, x-intercept, y is 0. So 4x plus 7, 0 is less than or equal to 14. 4x is less than or equal to 14. Divide by 4. And x is less than or equal to 14 over 4, or 3.5. Okay. So 3.5 on my x-axis, we're right over here. On my y-intercept, I need x equal to be 0. So I've got 4, 0, plus 7y less than or equal to 14. 7y is less than or equal to 14. Divide by 7. Y is less than or equal to 2. So 2 on my y-axis. And we have that less than or equal to, meaning I've got a solid line through there. Now we have to figure out, where do I have to shade? What you do to figure that out, especially if we're not in slope intercept form, you're going to plug in points. So let's test for my blue. We'll test to see if 0, 0 is in the solution. So if I plug in 0 for my x and y, is that less than or equal to 14? 0 is less than or equal to 14. That is true. So that means on my blue, I'm shading everything below the line because that's where 0, 0 is. For my green, I can also try 0, 0 and checking 5, 0 minus 7, 0. Is that greater than 49? 0 is not greater than 49. So it is not on the side with 0, 0. It's on the other side here. So then our final answer, our solutions will lie in this yellowed off area, but not including this green dashed side. Okay. The other ones are word problems, and if you need help with those, make sure you come in for our class meeting on Tuesday. They're very similar to the previous problems once you get those equations set up. Okay, good luck on this worksheet, and email me if you have any questions.